Oh, that's a really interesting idea that of like having bones like compute stuff. That definitely seems like
Yeah.
something that's like should be doable.
All right. What's up, everyone? We're back for another Polymath Salon. Today I'm here with Michael Ostroff and Dugan Hammock, who are both from the Wolfram Institute. And today we're going to be talking about some pretty interesting ideas, specifically how, fields that we think of as relatively concrete and formalized, like philosophy, cognitive science, and neuroscience, chemistry, physics, math. How would these fields, you know, be rederived if we sort of ran the sort of simulation of life all over again? What would be the key conditions and catalysts, pun intended on chemistry, to, rederive these fields for them to kind of reemerge, re-evolve? And then, I mean, you could even just say about like, how would people who, grew up somewhere else in the world that didn't know about any of this stuff, how would they eventually get to that same point, right? Like, what type of problem would they have to be solving where they'd come up with something and formalize it like chemistry or physics or mathematics or neuroscience or any of those kinds of things, right? And I think doing that gives you a really interesting idea into the fundamentals of the problems and the topics that they're trying to solve. Because I think when you figure things out from scratch and quote unquote first principles, as they say, you get a much. I feel like your knowledge tends to have a bit more depth that way because you really had to work through everything from scratch, from nothing in the beginning. So I'll let you guys talk for a bit if you any ideas come to mind on that.
So where exactly is this like entity which is trying to or group which is trying to recreate all this stuff starting from? Like what scale do they exist at? Are they like at our
I
scale?
mean, let's just say they're on Earth. Let's just say they're even let's just say another human on Earth, but they're some
I mean, it's
you know
also it's almost an equal exercise to try to think about the origins of where the
exactly,
traditions of philosophy and chemistry and math come from.
exactly,
Um,
exactly.
as a sort of
It's the same thing. Yeah,
before we started writing things down, these things were already like in motion, I would say. Although,
Yeah.
yeah.
philosophy got a kickstart with the Greeks, Plato and Aristotle, and what's the time frame on that exactly?
But I think you would have
2000
had
BC.
like proto philosophy, proto religion, in like
Yeah,
hunter gatherer tribes. You had to have. Right, because
right,
these are
right.
all
So
methods these are all really methods of coordination in a lot of.
okay, so yeah, the Greek tradition was like 300 BC, 400 BC, that kind of ballpark.
So
So that's
let's
that's kind of recent in the sense that we've been doing
so
um,
things like
civilization for
chemistry.
10,000 years, and then before that it was you know that's when we first started having nation states and writing things down. So before that, in a sort of nomadic, tribal sense of what humanity was doing around the Ice Age, I would say that it's quite likely that we had fire, we had some chemistry, we had some philosophy, and shamanism, some religion.
Right.
Um, I think a lot of what allows religion and shamanism to be effective is like, what are the prerequisites for that?
Yeah, and
Um,
a question I would pose that I've mentioned a couple of times in the past is like, what problem? Like, let's say you didn't accidentally stumble on fire or whatever, right? Like, if you had no inclination of the concept of fire, how in the world, like, what type of problem would you have to be solving where you think about creating a fire with stones or wood or whatever it is? Like, what type of problem would you have to be creating? Like, there's nothing if you were to look at raw meat or vegetables or whatever for the first time, it doesn't necessarily, there's nothing about it that would be like, oh, you need to like heat this up and dump it in fire, right?
Yeah, you would need an understanding of physics. And I don't know if you would really have one as like I guess some individual starting out from scratch and trying to figure everything out. You would probably need to like learn over time by just simply observing things and gathering information about your environment and how it all works. But I don't think you'd be able to just solve it all in your head, unless you were able to have all physics in your head.
I mean, there'd have to be something that drive. I mean, you could say, is there something in the information, you know, in the perceived information in, in the raw meat or the vegetables or whatever it is that tells you that you need to like rub sticks and stones together or whatever, or hit them or move them together in a certain way to cause a spark or smoke or fire or whatever. Like there's nothing I would think of, in sort of neurotypical perception where you look at that and you'd be like, oh yeah, of course we have to rub these two things together and then you get that. Like there's not, because I say this is a fun exercise because this also makes me think of like, let's say we are in that age right now and there's things that would be incredible solutions to our problems, but it's just nowhere in our headspace. Right. So I
Yeah,
think cracking
Right,
this,
right.
the sort of novelty of intelligence, the ability to generate something so incredibly imaginative and novel is extremely useful for today. Like, I think a lot of very good ideas are the ones that are just like completely out of nowhere, completely out of that distribution, and it happens to just be staggering. Right. I think those
Yeah,
are very cool ideas are they are they're good at doing that. But I gotta wonder, um, like what are some ways that you would be able to experience the phenomena of stones and wood or food where it would give you the idea that, oh hey, I need to combine these two things together. It's like
yeah,
like
yeah.
even
So
the
a couple
inception of
of
cooking, like
examples.
how would you know? Yeah.
All right. So putting my mind in that sort of mindset, don't know how to make fire yet, but I guess if you see fire, so there are, uh, you might encounter brush fires naturally, um, almost assuredly, and if you're in those sort of climates, and then so you would go investigate, you'd know that to stay away from it, but also you see embers, and you can harvest the embers for fresh fire and try to experiment with that. So that's one avenue for discovery. Um, and another one is if you are living next to like a volcano and you see that happening, to stay away from it, but also there are slow lava flows that can go up to and kind of poke at it with a stick and you get a stick lights on fire. Um, Now, as for like tools that make fire, friction based methods is sort of like that takes a while to get to because that's not something that is quite immediate. You would have to like know to keep
Right.
doing it, and stuff like that. Um, but you can kind of get there if you know that like a little bit of friction, like heat something up a little, makes it warm. And so if you keep that
yeah,
process going, then you could you don't know what happens, I guess. But if you just anyway,
you'd
another
be able to know
possibility
what
is
heat.
flint napping. Yeah, so if you hit like these certain types of rocks that like make sparks and also get warm, then you can kind of know that the spark will could start a fire.
So if you were to actually come across fire, you would know that it's hot, and you would be able to probably extrapolate that if something were to get hot enough, then it would like fire would appear. So and you would also notice that you could potentially notice that if like an animal were to like um die and it was like lying on some rocks which got very hot during the day, then it's possible that that would be able to cook some of the meat, and you could figure out that, but you wouldn't necessarily know from that alone that that would make the meat safer to eat, or that that was something that would be, I guess, desirable to do.
I mean,
Yeah. Well, it's interesting. Okay, so let's say you start using fire as a means to exterminate your prey, to kill them, to kill your prey animals. As instead of hunting, it's just, oh, you just kind of burn them. And then once they're dead and burned, then you go up and eat the flesh, and you realize that the burned flesh, has a different characteristic. And
Well, it's going to be difficult to kill something with fire. I mean, you wouldn't really have a flamethrower. So,
well, you might throw a, not advocating cruelty to animals, but you might take like a little rodent and you throw it in like a bonfire.
Another thing would be that even if all you knew was like perception of heat, like when your body feels very warm, is there something about that lets you know that if you cranked it up a bunch, you could get something to smoke, spark, or cause a fire? Like
not
just off of
really.
like, like, man, I'm out in the sun. Like, geez, I'm burning up right now, assuming they had a word to even describe that. And it's like, oh, if I crank this up to 11, all of a sudden now this will toast my plants or my meat or whatever it is. Like, I mean, it's sort of, I'm figuring out, what are the ways to extract the absolute most from like these very, very minimal models of information, right? Because I think that's also the thing that's useful to where we are now in current society, is to make those giant, giant leaps. I think there are people whose minds work that are probably better at this than others. I'd have to imagine this is definitely something that is trainable and doable, but it's just, how do you actually do that, right? Because this is also operating off the assumption that it was possible at one point for someone to just look at the thing and be like, oh, I know what I need to do. I need to make, fire from this thing, right? I mean, if you have Lego pieces, like it's sort of going to be a bit more clear, like, okay, there's only so many different ways this thing will fit together, right? Like that's going to be, even I think even if you gave it to a kid that grew up completely secluded away from modern society or just society in general, I think they would have enough of an idea and understanding of, you know, experience and perception or whatever, where they'd be able to be like, okay, yeah, these two blocks will probably click together. But then again, like I think like we've been surprised sometimes when we give tools to other tribes and they have just no idea how to use it, even though it seems very simple and straightforward to us.
Do you think the mindset which would be optimal for solving general problems would be like ideal? Would that count as like an ideal philosophy or something?
I mean, in a sense, I think this has to do with, things that we describe as plasticity and intelligence. I would say that it seems to fall somewhere in that, those category of things. Um, and obviously, I don't know how much distinct experimental data were, was there for stuff like this, but like, some people like, what person A and person B could look at the same exact object or piece of text and they could just get completely different conclusions. Even younger in age, it's not even necessarily about what they purposely had trained on to do things differently. Like some people just see things differently. I mean, on one hand, it would be interesting to see. You could also look at the way other animals make tools and do cooking. Because, I think part of when we call this thing a field or it's formalized in a way is like, okay, if you wanted to make, if you're cooking, however you figure out how to cook, right? If you wanted to turn that into a field like cooking or chemistry, you basically have to scale it a bunch. And when you scale things and you want them to work somewhat consistently and efficiently over larger periods of time, repeatedly amongst different situations, and, so generalizes, you would basically call it something like chemistry. Like, okay, I don't just want to cook. So you phrase it as, I don't want to just be able to, make this meat or this vegetable something that I can eat safely, but also I want to do that to other meats and other vegetables and plants and whatever. And as you sort of create, a generalized view of those things, it starts to look a bit like a proto chemistry or proto cooking or whatever, right? And I
So
think a
it's
lot
an
of math,
interesting
yeah.
point that some hawks and birds of prey will spread fire. They'll pick up fire from one place, sticks and embers, and start fires in other places, and that'll make animals spread out, flee, and they'll go. That brings them out from hiding, and then they can attack them, go pick them off. Um, Now it's a different point to wonder if these hawks ever eat the ones that didn't make it out of the fire that got burned and are like on the surface and they go eat something that is cooked. Um,
Right. That's fascinating.
and then for humans to come across a cooked like uh animal, and that was burned by like firehawks, and that would
But
give them an
see,
idea
again,
to use
I
fire.
think the cooler thing to explore with this, right? That has the most value is that, a lot of these things are assuming they've seen something fire or smoke like in the past,
Hmm.
right? And again, I think if you look at the way other tribes or whatever, I don't think it's necessarily just an intelligence or IQ thing in isolation, but like if you go to other, tribes or other societies right now, okay, I mean, the extreme example is you give an iPhone to a caveman or you give an iPhone to an early human like that, they're going to just throw that thing at you.
Yeah.
And you think, oh, it's so obvious that, oh, you use your fingers for this or whatever. But also think about like, you want a good example is look at how like senior citizens will use modern computers. There's not necessarily something about the way that it looks that necessarily tells them that, oh, this is what they should do. This is what they should press or this is what they should click or whatever. Like that's sort of a good microcosm of this whole thing right now is just give it to someone that grew up in a different, culture and time period. And, the things that we consider to be completely second nature, like, oh, duh, that's obvious. You should do this and not that. They're going to be completely confused and see things completely differently. Right.
Hmm.
And the bigger
Yeah, they don't
question
have
then
a pattern for it.
informationally, right, is like how do you create something truly new? Like what is origination is a big thing about this, right? I mean, again, you have the idea of a fire, this thing that seems to be, immensely useful to, I mean, some would say we wouldn't be here today if it wasn't for some kind of fire thing or whatever. But it's like, let's just say you never had the concept of a fire, you never saw it or whatever. How would you even come up with something like that? Like
Right,
and
right.
again,
So
like
yeah,
yeah,
you're
if you
inhabiting
kept trying to
Siberia.
rub stones together, put a bunch of friction on your stones and wood or whatever. Again, where how do you know to pick up the stones and wood in the first place? All that kind of stuff. The question is still there. But in the case that you do have those things, like even that alone, like there's nothing that tells you that hitting those things together is going to create something like that. And yet it happens. So where is that information sort of in what latent, you know, photonic space or whatever does that information exist and can be accessed?
Okay, so I want to think that a lot of new things that are made are like taking are connections between things that kind of already exist or extrapolations.
Sure.
So this is most of what people think about. Now, if you grew up in Siberia or something, it's always cold. Polar region stuff. Fires won't be a part of the environment natively. So if you and your tribe inhabit that, first of all, it'd be hard to imagine that humans could survive there without fire. But let's just say that they got animal skins on or whatever, and they just kind of exist in huts, um, and try to keep it reasonable. Anyway, assuming they could pull it off, would they ever think to make fire? And my answer to that question is probably no. That they have no concept of making a plan with that as a goal because they don't know that that exists. So in that sense, it would have the novelty of fire would have to be sort of discovered incidentally somehow if it wasn't like seen in
Michael?
the environment.
Right.
Yeah.
Yeah, no, I was just asking if you had any thoughts on that.
So if you were to have going back to like a forest fire example and like some food like animal or like berries were like burned to a crisp, like turned into ash, and a caveman came across that, they might now associate like fire with things becoming less nutritious And the idea of like actually cooking fire, heating food up in order to break down proteins in order to make food more nutritious, that idea might just seem incomprehensible to them after that experience.
Right. So
Right.
if you view fire as something that destroys stuff, you wouldn't think to put your food in there. You don't want to destroy your food.
Yeah.
Yeah.
Um,
And this is sort of why, like, I say, like, a lot of the ways that we think about, I mean, yeah, okay, it's easy to say information is observer dependent, whatever, fine. But like a lot of the things that we just think about and hold to be, pretty close and concrete and whatever, like if you were raised somewhere else in time or even in the world, like it would never ever occur to you, right? I mean, like, think about like if you learn like a skill that's, you learn a topic or a skill that's just like completely foreign to you, like, you're gonna pick up the piano or something. Like, let's say you had a history of being, a painter, maybe, and, maybe you were an athlete, or, even like, mathematician or physicist. Like, there's nothing necessarily sort of obvious to when you first play piano that, like, oh, this is the exact technique that I should use to get this effect and make this very nuanced thing. Like, even with martial arts, like when you sense certain punches or kicks or grabs or whatever, like there's a lot of very, very subtle nuances to it. That's like, if you first stepped into it, even people that had martial arts experience, they'd be like, I would have never thought of even doing that. Right. And the point is to close those gaps. Like, okay, yeah, if you do the thing long enough, you may figure these things out through feedback and, playing the game of it over and over and over again. Fine. But I'm saying, like, can you first look at something and that thing is just like immediately obvious to you? I think this is very much tied into our definitions of intelligence and qualia and perception and all these kinds of things, right? I mean, if somebody has never driven a vehicle like object in their life and they step into a car, is it immediately obvious that like your hand should be here on the steering wheel or on the shifter, or which pedal is the accelerator or the brake, right?
yeah.
Yeah.
Now it would be
Yeah. Right. So
especially
yeah, there's
tricky.
the things.
Yeah, good.
I let my friend drive when I was living in Malibu, and I let him drive my car, you know. And this guy was like using his right foot for the gas pedal and his left foot for the brake, and he would brake while his at the same time. So it was like both pedals down. And luckily, my car like knows to like disregard the gas pedal when the brake pedal is being depressed. But oh my god, that didn't happen again after that.
That's funny. Yeah.
I'm
Yeah.
I'm guessing you didn't have let them drive your car after that.
No, did not.
Oh, okay.
But
Yeah.
these things get especially even more interesting. Like what if both pedals are identical? Like they're the same shape, the same depth, same position. Like they're just right next to each other as two
Mhm.
rectangles,
Oh,
and
you
they
wouldn't
don't look
know. Yeah.
any different. You would have no idea. And this says something about the way we interface with the thing, and then what's sort of interior to that, what's its internal state and mechanism or whatever. Like, if somebody sees a car from the outside and only certain angles of it, they're not going to necessarily know under the hood is this engine with these pistons and whatever. Right? It's a very similar thing.
Mhm.
Like to us, well, yeah, that's obvious, sure.
Yeah.
But
Or you get up on a tractor and like there isn't even a gas pedal. They're just like these levers. One of them
right,
controls the throttle to the
right.
engine.
And the thing that's interesting is like, even I'm sure, many of us have plenty of friends or people we know that aren't necessarily very knowledgeable about, say, anything about cars or vehicles, other than, you press some pedals, you do whatever. They know there's an engine or there's sort of a transmission. They don't actually know exactly where it is, the configuration of it inside the car, how it works, whatever. And like, if you were to, say, okay, what does this piston do? They may not even know what that is. It's there. You open up the hood, you look at the engine, all this, you'll see everything.
Hmm.
But there's nothing technically about looking at the car on the outside that tells you that that's what's there inside. And yet it's there. It's true. It's there. And so I wonder if there's ways of experiencing information in such a way where you would be able to come to that conclusion. Because it's the same thing going back to the thing about the fire and the sticks and the rocks. It's like those things will lead to a fire pretty consistently. But what is it, this could maybe also be a thing about working memory or whatever, but like, yeah, if you kept, the concept of your hands and the rock and the texture and all the things that you could sort of see, would that be enough to be like, I wonder if I, mix these things together in a certain way, do I get this thing that looks like a fire? Right? Like, for instance, you could have somebody trained on, let's say basic physics, just sort of high school physics. Is there something about what they're getting there from that tells them, M theory or whatever? I mean, it's technically there, but there's nothing about their perception of it that gives them that information, unless maybe there is a way for them to get to that conclusion from that.
Right. M theory only exists because they had instrumentation to probe, subatomic particles, let's say.
Yeah.
Right. So I don't know. I think,
Yeah. So it's interesting to think about the origins of philosophy. So like, what is philosophy at heart? It's sort of trying to get explanations for why things are the way they are. And what does that necessitate? Sort of, in order to try to have that as a goal, to say I need a story that explains a phenomenon, you need the concept of a story. And so that's like a linguistic construct. If it's not linguistic, then it's certainly a cause and effect relationship between thoughts and notions. I think that language is probably a requirement for being able to develop sophisticated enough thoughts and notions to connect it to and to have, it's like language, using language allows the brain to develop sophisticated thoughts or thoughts with complexity. And so you need to like have a complex knowledge of some phenomena and then it's complex and you're trying to explain it. You're trying to have like a story or an explanation for it. And that requires a certain complexity of the thought. And I think language is useful for allowing that complexity to take root in the mind. So
I mean, then now then you also open up the door of if language in some form is a prerequisite, how would we have, how would that have originated? I basically
yeah.
do
So
have the belief, yeah.
I would suspect that language came about because we have this vocal apparatus, which with enough nuance that we can create signals to each other, a lot of different signals, a lot of different words, let's say, or phonemes or utterances. And proto-language is probably, trying to have different names for things and names for phenomenon. You might
Right.
want to be able to yell out tiger if you see one.
And the method of delivery and the medium of that is extremely important. If it's not, I think there's internal means of coordination, which we would say are sort of thoughts and our, ways of kind of talking to ourselves and thinking to ourselves. But the
and
crazier
I
ones,
feel like that is sort of cause and effect relationships between
right,
desires maybe or things you're trying to reason through.
right, right. Yeah, I don't know. I mean, I think I think a lot of philosophy would have just been just asking why. Like, sometimes like there'd have to be enough of sort of the conditions in place. And again, you get back then to like the origination of the condition. I mean, this is a big thing about like where people will sort of make fun of, like, you could ask why forever, infinitely. You could just keep asking
Right.
why, whatever, right? And
But how many
you know,
animals ask why?
right. But I do think though that like a lot of the things that, the reason we at least got to the point where we have, some would say we've achieved quite a bit as a species. Then you could also question how good is the metric that we say is good. I mean, again, these are sort of the jobs of philosophers, right? And I would say that asking why probably had a big part in this, because it's also like if you're solving a problem, you also sort of step out and you ask for a minute, well, is this problem even worth solving?
Mhm.
Like, I'm sort of very fixated on this. It's very easy to happen. And sometimes you're like, is this actually something worth putting in all this energy and whatever into, right? And this goes from just ideas you see for companies and research in the world. And some of it is like, you would also just, you wonder, has anybody sort of stepped back and just asked why this? Like, of all the things,
Yeah.
why this instead of something
Mhm.
else? Right. And then, this is also like just something that happens in everyday mundane life. Like, why would you, eat this or drink this instead of something else? But then you open yourself up to sort of the infinite possibility of the other things that you could be doing if you mess with the constraints enough. Right. Like, why am I talking to you guys right now when I could be doing something else? Was I, explicitly weighing out my options? Was it sort of something else? Like, I feel this ties into, game theory, decision theory, the way we sort of make choices about things and strategize, right? Because, a lot of strategy, especially like in sports, when you're very quick moving, you're not necessarily thinking about it and mapping it out in your head, right? You're sort of just vibing with it and you're feeling it. It's what you'd call an instinct.
Yeah,
When you're
yeah, but
trying to
part of
make the
that
right
is sort of
decision.
in the same way you have muscle memory, you also have like pre-canned thoughts that you thought about thoroughly about the dynamics of like where the ball is and where it should go beforehand while you're learning the sport. And then once you have like those relationships solidified in your mind, then like you can go from, you know, thought to thought, cause effect, pretty quickly, almost subconsciously, um, as sort of thought memories instead of
Right.
muscle memories. And then you're like, okay, I need to go here because this relationship between these players and the ball is about to happen. And you feel that happening in your mind, and you can just hop to the conclusion without much effort of thought.
I think something interesting to think about too, and I think mathematics is almost unique in this, in that if you were if you were rederiving the field of engineering or physics or chemistry, you would probably eventually land into creating something like mathematics. If you really wanted to get down to the details and new processes, you're eventually going to have something that looks like mathematics,
Right, right. So
right?
if you're
Yeah.
dealing with numeric
I mean, even
quantities,
even if you're just, recreating
then
an
you're
object, even if you're sculpting something, if you needed to sculpt it, in a certain way enough, eventually those instructions and formulas will start to. I don't know if it cut out for you, Dugan, but I was
yeah,
basically
yeah.
saying,
So a
yeah,
sculptor dealing with shapes, they're gonna have to know about like the shape and curvature of the nose. Um, whether or not they're trying to whether or not the mm, equations for curvature are going to come out at them, or that's going to intuit from I can see a sculptor just dealing with shapes of stuff from a visceral understanding. If they're trying to map out coordinates, for instance, cartography, cartographers I think would come across, since they're mapping out the sphere of the earth, they would come across curvature values, and they're dealing with coordinatization, if they're, let's say, looking at longitude and latitude, because that's what led to, deriving a lot of curvature and stuff, equation wise in mathematics, is that sort of pursuit.
I have an example maybe on how things like geometry, at least in terms of the curvature and shape of things, would have been done. Because I used to think about this a lot when I would, try sculpting things. I'd be like, how would I actually communicate the instructions of building, of sculpting this thing to someone that didn't have hands, or they had to make it outside of the way that I'm currently doing it. So I think a lot of the way we formalize the depth and the way that we'd formalize things that where it start to look like mathematics or geometry would be like, okay, you can no longer use your hands to sculpt this. You have to use something else, right?
Yeah.
If you start to have to use other tools and come up with those things, you're eventually going to have to start describing things geometrically. And this is actually I think this is a relatively simple thought experiment to think about, in a pretty short amount of time. Like if the person is identical to me and they can look at how I'm doing this, okay, that's easy, whoop-de-doo, right? Now the tricky part is gonna be like, if I want to make changes to that in a certain way repeatedly, in consistent kinds of changes, or if I wanted to get somebody else to make this that didn't have the same tools as me, right? I'm eating, certain food with chopsticks, but then I want someone to try to eat this, eat the same food or make the same food with, a fork or a spoon or whatever. Like they're going to have to think about it in a very different way, almost more abstractly. You're going to have to represent it differently in their head for them to be able to make that, to bridge that gap, right? It's easy if I just have somebody else and they just can imitate it. That's easy. The trick is making that transformation across a big difference. Does that make sense?
Yeah, I
Say
guess.
that last part again.
I was saying, I think part of this comes from, the way you're abstracting and generalizing and representing that information comes across these bigger gaps of similarity, right? Like
Yeah, yeah.
if you wanted to turn a bicycle into a car, you're gonna have to almost represent those things much more abstractly, which would look more like mathematics to make that, to bridge that gap, right? And if I'm cooking a dish and I'm sculpting something or whatever, again, it's very easy if I have someone that's exact, if I have another mind or agent that's, very identical to me, because then we can just mimic things. There's not
Hmm.
necessarily a need to have this sort of deeper abstracted understanding. It's only if you really want to make changes and transform it. Whether you're trying to transform that as the same people to something different, or you're trying to communicate it to a different kind of agent with a different set of tools and apparatuses to make these things. I think it comes from that difference. And it's like what I was saying about, with the language stuff about, if I wanted to think about making very dramatic changes and transformations to my drawing, my 2D drawing on a canvas, I would think of it differently because it lets me have more room to mess around the shape. The other example that I'd give is like, you could have a Lego set, and it's only until temporarily remove the pieces from each other so that they have the degrees of freedom to be rearranged. It's the
Hmm.
same exact Lego pieces. Physically, it's not changing. The composition hasn't changed. It's the arrangement of the pieces at that scale that's changed.
Right, right. So yeah, so if you're seeking novelty, trying to come up with new things, new ideas, um, you know, one strategy I would say is to take two things that are different that you think are have nothing in common, and then try to look for what commonality,
Yep.
or try
Oh, I've been
to
doing this my whole life. It's one of I will just do it all day long. Like I would do this all the time. I'd start off by taking two or three things together, like a sign, a truck in a road, or a bug, or I'd take a number and a color, or like a graph and like fertilize it, like just random stuff, and just be like, okay, how can I connect these things in like a functional way? Right.
right.
And it's
Okay,
it's
so then you
such a
would
fun exercise.
decompose
Yeah.
each of these disparate things into components that specify their nature, and then mix and match some of the components, I guess. You take an aspect from this one and an aspect from this one and see
Right.
if you can make something else that's in the middle.
Yeah, I mean, that exercise in particular has actually been extremely useful. I mean, I think a lot of the ways I think about things definitely, I think, came from doing that type of stuff, right? And then, of course, that translates into other things about language and representation. But have you been doing that for a while, by the way, Dugan? Is this like a thing that you've been doing for a while?
No, I just kind of came to that realization like 5 minutes ago
Oh,
that if
that's
you
funny.
wanted to,
But yeah, it's
I
uh
mean, I
it's
mean,
something I
it's
take very
been in
seriously.
my mind that like for years and years that most people don't create genuinely new outside the box thoughts. That new creativity is incorporating components from things that are existing already, and then kind of combining
Right.
them and then pushing them in degree and in kind. But to
Yeah.
as a strategy to make the most possible novel things, as a strategy to say, oh, let me take things that have nothing in common, that are like at polar opposites of this,
Exactly.
in the set of things that exist, take opposite things and try to make new connections between things that you don't think are have connections yet.
I mean, if you think about Star Wars in a lot of ways, especially as the lore and the canon kind of expanded, like that was basically taking like sort of standard sci-fi. You got laser swords and spaceships, and oh, now they're a bunch of religious monk wizards.
Yeah, yeah. I mean, it's samurai stuff in
Like
space.
complete juxtaposition.
I mean, it's family dynasty dynamics with like samurai warriors. That's the way I see Star Wars. It's just in a
Yeah,
sci-fi
totally.
space setting.
Yeah.
And so
Yeah,
it was so fresh.
Vader's helmet was based off of the samurai, I think.
Okay, right. That makes sense.
And do you know how lightsabers were come up with apparently?
No, how?
So I got into this for a while because I was obsessed with like Star Wars ships and lightsabers and blasters, like the engineering and aesthetics of the whole thing, like incredibly obsessed.
Yeah.
Almost like too obsessed, right? But so one of the things was like the lightsaber when I think Lucas and the team were originally making this. You know what was the original lightsaber? It was a camera flash, the Graflex.
Oh.
And then they got, I think, some motor thing to spin a dowel with like 3M reflective tape so that they'd shine a light. And if you'd
Mm-hmm.
run this motor inside the hilt, inside the Graflex that they'd hollow out, it looked like the lightsaber. And if you look at like original footage of like A New Hope before it was ever called The New Hope when it was just Star Wars in 1977, and you
Yeah.
look at like what the original lightsaber looked like before they added the color onto it, like you can tell, oh, this looks like a little spinning rod. It's got this reflective tape on it, and so it gives it that pulsing nature that we attribute with the lightsaber.
Yeah.
Right? Like I thought that was the coolest thing ever. They make one of the most famous. I mean, it wasn't at the time, so you're looking back at it with retrospect, but like you make one of the most famous things from all of storytelling and cinema by just randomly taking uh you know a camera flash, the Graflex,
Mm-hmm.
Graflex, right?
Yeah.
Like, and it looks cool. Like, I mean, I can tell you this: when the designers are making the Graflex flash, there's nothing that would have made them thought it would have been used for something like this. But it's still the same information. That the Graflex, the hilt is still the same.
Yeah. So that's designed with the purpose of making a sword that's made out of laser, I guess. I mean, yeah. So it's like, where did George get the concept for it?
No,
I guess,
man,
yeah.
I'll have to
You
ask
want
him.
it.
I'll have to bring him on to Salon.
I mean, on the one hand, it's like, oh, you want a sword, and on the other hand, you want laser, so you get like a laser sword. Maybe that's a thought process.
Who would have thought bringing those things together? And that,
Yeah.
like, I think there's a lot you can learn about the, you know, cognitive process of creativity and and origination from all sorts of things. And I think, I mean, I think especially on kind of the pure maths theoretical side of mathematics, I think the theoretical side of any field generally you can get, if you go deep enough, things can get very, very kind of creative, at those levels. But I think at scale, I feel like the arts tend to value that more because like the point with like an album is that each song is supposed to be different. The
Yeah.
beat shouldn't be exactly the same, the lyrics shouldn't be exactly the same, you can't repeat things too much. When you're making a movie, like even if it's a shared trilogy or series, the whole point is that you're making something different each time. When you're manufacturing an object, you're trying to get it to look the same every time. The creative
Hmm.
process is that you're actually trying to get everything to look different. And then, some would say maybe you want some kind of invariance somewhere about they share a theme. But that's always the thing that's kind of enamored me about the creative process and the arts versus things and technology or whatever, right?
Hmm.
Is there is that element to it. And like, yeah, like even in Star Wars, there's like these different crime syndicates. There's like the like Darth Maul's planet where he's from, Dathomir. and like I remember I think they're called like the Night Sisters and all that stuff. Like that's legit like occultism and witchcraft in a space TV show. Like who would have thought about combining of all those things together that?
I mean, it seems like a good idea to me.
Well, to us, but it wouldn't have been at the time.
I mean, there's Lovecraftian stuff, and that is inherently like space like themed, and like Eldritch horror and like sci-fi kind of go together like very well.
And actually come to think of it, um, to your point, even Dune was like that before Star Wars was ever a thing. Dune got quite, you could say, as Safal would say, esoteric at times, from what I recall. Because
Yeah,
Dune was sort of this thing where they're technologically advanced, but they're still sort of mystics, and Dune was interesting in that you have this kind of technologically advanced civilization with all sorts of things you would describe as modern, and yet you have these kind of mystics and psychics and all those kinds of things, right? And it's interesting that I think Star Wars definitely did borrow from Frank Herbert and Dune quite a bit. I mean, Star Wars got inspiration from a lot of different things, and when I say Star Wars, I don't mean the first movie from 1977. I mean just the sort of lore of Star Wars as a whole, right? It was sort of a mishmash of all these different things. I think you have, if you're a futurist or you're a writer, like you have more room to explore these things. And I think the thing that would make, a good film series or sci-fi book series extremely good is if you can't tell the difference between that and like a scientific paper. Like something that's been rigorously, thought about and trying to make some clear, concise predictions and ways things could move forward. And if that was a narrative in a story. In other words, you'd basically be saying you're trying to make a really good prediction,
hmm,
right?
Yeah.
You'd write it as a way that would be making a very good kind of prediction. Um, but I'm
Honestly, I've
I'm
thought that
I'm
my
interested in the things that break the prediction.
I was just gonna say that I've thought that my dimensional collapsar theory stuff would make really, really good sci-fi.
I'd agree.
no
I would
doubt.
also say
Yeah.
my language and altered states idea stuff would also be kind of very much sci-fi, mysticky, into that territory. Yeah,
Yeah.
yeah, it's interesting, and it's also interesting that it's possible to think about these things. Like, oh, it's possible you could combine in your mind as a human with the kinds of minds that we are, that you can combine these two very, very different things and get something from that, right? And it just makes you think
Yeah.
about other models of cognition, whether it's computers and AI or other animals or whatever. Um, I I think there's just a lot to explore in this. There's I think with the perspective that we have right now, we tend to speak a certain way about the capability of our mind, as humans, or even augmented humans, with BCIs or AI, or dogs, ants, bees, whatever. But I think my sort of view on this stuff, which is always evolving and adapting, but the one part that's kind of stayed the same throughout all of it is that there's something more to the way we perceive information and think about things. Like, I mean, I'll put it to you this way. We wouldn't necessarily, if we look at a honeycomb, we wouldn't necessarily think of using it in the same way a bee would, right?
Yeah. Yeah, definitely.
We don't necessarily, um,
But yeah, we would not think to put our young in there.
exactly. Good point.
Feed them.
Would definitely not think of doing that. Yeah, that's a good one.
But
I like
it's
that.
a question like would we understand that that's the best packing for cells,
Right.
for sphere packing on a
And you could
two-dimensional.
say, you could very well say, is there, I talk a lot about, sort of, fusing minds together in a very kind of coherent uh way, coherent natural way. It's like what, like we were saying earlier, take two very different things, combine them together. What does, the qualia and the mind and the experience of a bee and a dog look like when mixed with a human? Do you get a more general purpose mind by doing that? Like, and a lot of these things, I think you can get some grasp of that, of the feeling of it when you actually try to work with animals. Like
Mm,
there is a specific way, I think a lot of times when people train animals or try to communicate with animals or even like very young children, they sort of section it off away from, the way that they would communicate with their friend or another person their age and their background. But if you keep your mind, if you sort of connect those two and you think about, let's say I'm talking to you right now and then I have a
mhm.
dog or cat next to me, and I think in my mind as if I'm talking to another person, but I think about, oh no, wait, they're sort of speaking a different language. I have to phrase things differently. You sort of keep it all under one window. And so it's all kind of abstracted together. And you start to
Oh,
realize that, oh yeah, there is sort of this other way of experiencing and feeling about things. Like I think you can express these concepts to dogs or cats, at least to a degree, but there was a way to do it that we don't usually do it, you know? I
yeah.
think a lot of this, I think a good way of thinking about this is like, yo, like let's if we if we put a bunch of humans with other dogs and like a very sort of a diverse survival situation, like you would basically end up having some kind of coordination system that the human and dog are using, right? I think there's ways of designing things like that. I'm not saying we'd ever be able to run an experiment like that, but I think I mean, I think you can also just look at the way other tribes that have their dogs with them, the way they communicate. Like, how does that dog know about all the things that they do, and this is the place to attack this thing and do that? Like, there's nothing in looking at the beehive or the plant or whatever that immediately tells you that if you've never been told to, right? And so I think part of the way we would interact with other animals or whatever is we also have to sort of simultaneously change an aspect of the way we think, right? Like what if
Yeah,
you try to
so yeah,
teach a
to
dog
communicate with an
mathematics?
animal, you have to have like commonality of what's important.
I
I'd
think
imagine like training a sheepdog, you have to have gestures and whistles, and they're
Right.
attentive enough to you and paying attention to the same things you are, that you can make associations between, jump over the fence, get behind, go to the left around the herd, and then circle around. Um,
I mean,
mm.
as an exercise, like how would you teach your dog or your cat mathematics? Not complex mathematics, just simple stuff. How would you do?
I mean, I'm pretty sure I could probably teach my little brother who's a beagle calculus if we both tried hard enough. He's like he's really intelligent, but my little sister Lucy, not so much. I don't
Not
know
as
how much
much.
I would be able to teach her. Yeah.
Well, I mean, it's interesting that in order to optimize the problem where, you throw something into the lake and you're walking along the shore, so they have to plan a route over land and then swim the rest of the way. And, the optimal balance between land and swimming uh, paths in order to minimize, time to minimize the time to get to the object is essentially second order. You have to solve like a quadratic
Right.
if you work it out on paper, but
Right.
there's enough intuition that they sort of solve it already without that
Right.
need. So they kind of do like a little complex algebra or calculus problem, but solve it just by trial and error. um
Well, there's also
yeah.
something to be said about, if you think about it for a while, if you really sort of think about it in your head for a while, if you were to run sort of a simulation of how you would train a very young child or an animal or whatever, or even in a sense, someone that just doesn't have the same sensory apparatus or language as you or whatever, like it's sort of about setting the conditions to get them to learn it. It's like, you if you want someone to really understand something, you don't just tell them that. They have to sort of work it out in their own way. But what you're trying to do is give them like the minimum opportunity and conditions to get to that point. Right? Because I think you even just learn this with kids and like independence and all that kind of stuff. Like you sort of have to get them to understand why they're doing the thing that they're doing. Right? It doesn't have
Like
the
a
same power otherwise. Go ahead.
so like a minimal algorithm for either learning or teaching.
Right. Right. Which also, I think, and speaking of minimal models, goes into like what's the minimal model of something you have to do to extract the idea of fire from that, right?
Yeah.
Like even even if somebody knew about fire and they just looked at a car engine and they didn't, feel the heat or see whatever, how would they know there's little teeny tiny explosions happening inside?
I mean,
It's
maybe they
also like,
could deduce it from the sound.
well, what if there isn't a sound? And then the same argument goes for like, you could look at basically anything, but it doesn't necessarily give you the idea that there's atoms inside. Now, I
True.
think the idea of an atom is different because it seems to be a bit easier to just keep dividing things and breaking them down into simpler parts. And you think, okay, what made this up? But then something else had to make that up. I mean, you wouldn't be able to specifically describe the exact physical properties of atoms, electrons, protons, whatever, just like that. I mean, I think you kind of could to a degree. You'd probably use different names and it would probably vary a little bit, but I think I think that's one of those things where you just drive into it enough and you can eventually, which is sort of, I mean, isn't that sort of how the Greeks came up with the idea of an atom?
Well, the idea of an atom, if you look at things and just think that you can keep subdividing them like further and further, then the idea of an atom's not going to make sense to you because you would just think you could keep dividing the atom further. I mean, which you can, but then you'd get down to the elementary particles, which you can't really divide into any new particles.
Right. So
And
like
then
an atom was the undivisible thing, atom in Greek, and
Right.
I guess you think of materials as being either continuous blocks of space with a certain property, material property infused in it, or it comes down to a uncuttable thing at the bottom of it, saying this material is made out of this material's atoms. Um, and I think they could probably suppose that atoms would exist, but certainly not in this sort of as conglomerations of more subatomic particles. But it is really a really interesting like journey story that we got down to what matter was made out of, and we found out that it was made out of electrical balls, and made out of electricity. Like an atom was at first just sort of this cloud of electron. Before they were able to like pierce through the electron cloud, it was just, oh, we found out what matter is made out of. It's made out of electricity, bizarrely.
yeah.
I mean, that also makes you think of, I mean, how the heck would you have, let's just say someone, a young kid is looking at a PCB or something, a circuit board. That's using electricity. That's pretty clear. Like we're harnessing electricity for that in a very controlled way. But there's not if you just look at that and you didn't really have any other context, there's nothing that necessarily immediately tells you that this is using electricity, the concept of electricity
Yeah.
to make the whole thing,
I mean, it's
even though
weird to
that's what
think
it's
about
doing.
the Ark of the Covenant is basically constructed as a giant capacitor.
Right.
And so, did it operate as a lightning rod? Would lightning strike it?
Uh,
And I don't know. Anyway, I would
Yeah, no, I
imagine
mean
static
that
electricity
example in
was
particular is interesting. Yeah.
come across first. If you have like wool and you start like you have wool and metal or some material that'll get a static cling to it, and then you get a spark off that.
And this also reminds me of the thing about like the idea that, people will say just because you're good at one thing doesn't necessarily mean you're even good at a similar skill or topic. Right. So there's things people talk about, there's plenty of people in history that were, marked geniuses in their field, and then other fields they were, clueless or whatever people would sort of, use to describe them. Um, but also it's just like I know a lot about cognition and things in philosophy, but that doesn't mean I know all the other things that people know, right? Like that,
Yeah.
there's something about that transfer over, and transfer, and I mean that in transfer in the way we talk about intelligence and far transfer and near transfer, that transfer and that association, even if it's there in some other, latent space or wherever else, whatever you could describe that as, doesn't mean that you're necessarily having access to that and using that and controlling that, right? Like, I think if we want to make big sort of changes in our own minds or in the minds that we will build, I think focusing on this novelty thing is like super, super important. Because a lot of times when we think of something, I mean, it's sort of easy to be like, yeah, you take these things, you add them together, you get that. Like that's a bit more approachable. It's going to be like, but what's sort of the thing completely out of what's predicted and suspected?
Mhm.
And this once again ties into the blind spot you don't even know you have, the unknown
Yeah.
unknown. Are you seeing how this is all tying together with the big theme of this thing, right? And I think whether or not it is true or not, I find it to be helpful to think that it is possible because it at least puts me in the direction and mindset that it's worth exploring and trying.
Yeah. And if you don't think something's possible, you're probably not going to be able to pull it off if it is.
Right, right. And again, the interesting thing about that is that I'm just aiming for novelty. I'm not actually thinking of a specific thing, right? In
Mhm.
my mind, the goal and the focus is novelty. But I'm telling you something, I'm going to come up with something that I don't know. Like, isn't that strange to say that out loud?
Mhm.
I'm trying to create something that I can't create or don't know.
Well, you can create it if you succeed in creating it. You just don't know what it is
Right.
prior.
Right, but isn't that interesting that you can't I'm just saying is something new or novel, right? Something kind of completely original outside of the box on that, right? I think this reminds me of like people who have been on extremely intense meditative experiences or psychedelic experiences. I don't know if you've heard about this, where people say like they experience like a new color or a new sense, like a ghost color, something like that they would call it. And then
Yeah.
then that makes me think about, well, what in your mind tells you that something is new? Because technically, if I could give you sort of a medication or train you to forget things, you'd experience the same thing as new. Like the same thing you see every day is new. And sometimes this
I'm get
happens to people where they just forget stuff and they're like, oh, I don't remember seeing this. This is completely brand new.
It
Mhm.
must be encoded in their memory as some color, which is not really something you can't really create out of like red, green, and blue under normal conditions.
No, I think well, so the recent discovery of a new color, what was it called? Polo, maybe? I forget what it was called, but
Yeah, I remember
It's
that.
not a
Yeah.
new color.
well, it's stimulating the retina cells that are which is one of the retina cells, one of the cone cells, the one for green, without stimulating optically the other ones with the laser focused laser beam. Where usually, you would have green and a little bit of the other ones. Like they never fire one at a time naturally. And when you isolate one of them, you get some qualia, which is not combined with the other qualia for green and red, blue. But the green one by itself produced a new color. And so, I can't wait to hear what they say about the blue and the red emissions, stimulating those
Well,
cone cells specifically. There would be two new colors. And then, there's a
okay.
whole gambit of things outside. If you stimulate them at different, individually at different rates that are unnatural combinations, you can get some new colors. For psychedelics, my theory is that when someone like goes into one and sees color that they've never experienced, that it's the biochemical um the substance that they took goes into their the cells that are processing their vision and stimulates those. So if it gets into the retina, let's say, it might stimulate rods and cones in ways that are unnaturally combined, unnatural combinations of them, and artificially stimulate them and produce colors which haven't been seen.
My issue with Cielo is that I think it's technically I think we were able to see it before using a combination of negative colors like when you're looking at a color for long enough and those like cones corresponding to it like kind of like burn out and you look away from
Oh,
it.
that's a good point.
Yeah,
You
and
sort
like
of
a
have that retina
combination of
burn.
yeah, and then if you look at some other set of colors, I think you could probably isolate the colors of one of your like cones without like stimulating the rest or like getting the result of stimulating the rest. So I'm not entirely sure that this like Olo thing is genuinely a new color, especially like because it's still in that like one of those like three colors of like red, green, and blue. So
Yeah, they described it as being hyper green, some sort of like neon fluorescent thing. Yeah, like when I close my eyes and like look at the like a bright light or something, kind of have very vivid colors. I mean, there's also stroboscopic like stimulation. You close your eyes and have a strobe pulse on your eyelid, and that'll stimulate your retina. And depending on the frequency of that pulse and the patterns of the pulse, you get different, very different visual effects. Do you know about that?
Yeah,
not really.
I may or may
Have
not
you
have
tried
tried
it?
this in the past. I may or may not have tried this in the past.
And I worked for a guy who had one of those machines, and so I experienced this a lot. And it's like being on psychedelics, but you're not. You just sort of like close your eyes, turn this machine on, and you have like this wild patterns and visuals, and you just turn the thing off, and then like you're fine.
I mean, again, the thing with all this, right, is we're saying that you're combining these things to get the thing that's new, right? You're
And oh yeah,
combining
I was gonna
multiple
say
different
that
things. Yeah.
the colors that would be in your vision while that's happening is they seem very vibrant, and I would say that there are probably like Olo type of colors in there that you see unnatural combinations of
Right.
stimulants.
And but you're saying it's like a hyper red, a hyper green. You're saying it's like this thing that's already familiar. Can you use new to describe new? Like, like I think
Yeah.
a good example of this is like a language. Like, you're learning Chinese for the first time. Your main tongue, your main language is say English, right? How is it that all of a sudden you start to be able to understand Chinese? Right? It's something completely foreign to you. And now all of a sudden, after a bit of practice, you can start to understand that. This thing that was otherwise completely new and foreign to you, right? And it's like when you get to that point, do you describe, I think, having tried to learn languages or whatever in the past, it's sort of like this. I mean, I think this also, a lot of this depends on who you're communicating to, right? Is that you'll say that, this thing in Chinese is like this thing in English or vice versa, right?
Mhm.
But can something be kind of self-descriptive? Like you know, you're not describing Chinese in English terms. It's like, when people are learning something new for the first time, they'll say, "Oh, this thing that you're learning is like this other thing that you know." To like draw a branch of similarity and invariance between them, right? Yeah, driving this car, driving the sports car is like driving your truck in this way, but it's got some differences, right? Riding, a motorcycle is sort of like riding a bicycle, right? Or, skateboarding is sort of like longboarding. Anytime you do these things, I think again, think back on what Howard was saying before about combining the two very, very different, distant things. Is that we tend to use that and the process of analogy a lot. That we're saying there's something that we're familiar with that we already know, and then we're creating a branch of that over to the thing that's new in order to understand it. But can you understand something new from scratch? That's sort of the thing that I'm getting at with about coming up with the concept of fire without ever even having that in the first place. Right?
Mhm.
If you already have smoke, you could say, "Oh, it's sort of like fire." Right? It's like, but remember, when you're talking about the colors, you're saying this, it's like a hyper red, it's a hyper whatever. Right? Is there a way to have sort of something completely novel that's like descriptive, if that makes sense. And even then I use the analogy.
If you knew you've been colorblind since birth, you'll never know that missing color.
Right. That's why
Is
I
it
get,
possible for them to think about it?
right. It's also like, a color you've never seen before, a sound you've never heard before. I can say a sound I've never heard before. That doesn't mean I know what that is. Right. But interestingly, you know, if you were to expose someone to a sound that they've never heard before, they would probably be able to identify that, at least to a degree. Like, I can tell you if there's a song that I've never heard before, or a movie that I've never seen before. I can do
Yeah, so it's
that.
interesting. Like, I was just thinking about this because the space of sound is sort of parameterizable, and that you have a waveform of this particular length that can't be too long, and then you repeat that. Or essentially, you have a spectrum, and you highlight certain notes on that, certain regions of it. You're selecting, you're trying to recreate on a spectrogram some horizontal, some pattern around a spectrum, and so you can almost sort of algorithmically morph through that space of all possible sounds. And synthesizers were sort of the first step in being able to have apparatuses which could play any particular set of overtones. But then again, what makes a timbre is sort of how the thing modulates over time. So how much does the sound change? Like a violin, you kind of have like a wobble. So it's not just one sustained set of overtones. It's a dynamic process. Does that wobbling in the violin, is that not just taking one wobble and then repeating it?
Yeah, that's true.
I mean,
Yeah.
mess around with guitar pedals and stuff, and you get tone. You get all these tones that are so different from each other.
I mean, it's just interesting that, yeah, like I can know if something is new to me. It's not like I'm referencing, like, I know what something new is and it matches those kind of specifications, but like, you can know something that's new to you, right? Like, I've never been in this area of town before. I've
Right,
never,
right.
again, whatever. Like, it's very interesting that's actually possible, or at least it seems to our perception that's what's happening, right? And then I
Isn't that
also
just a
think
memory
about,
check? You're just like, you're in here, you cross-reference it from like a set of memory that you have. If it's not in there, then you know that it's not new, novel to you.
that is true, that it is doing a kind of memory check, but it's also about, it's memory. But what do we mean by memory? Because even if it's something more intangible, like an idea, we can say, I've never heard an idea like that before. Emphasis on the like, the analogy
Hmm.
thing. You've never heard an idea like that before, right?
Yeah.
Like, I just said it again, like, but it reminds me. And again, see, now again, I'm tying something kind of novel and unfamiliar into something that isn't. But the example that I was thinking of was people that, again, they're on these sort of very, very intensive advanced meditative retreats, experiences, or especially with psychedelics. And they go sort of past the ego death into all sorts of crazy stuff. And people will say they experience things that they can't describe. They don't have a language to describe this. They don't even have a way of thinking about it. They just know it. Like, that's such
Yeah.
a strange thing to say. And ironically, they are describing it. They just use language to describe it. They're
Uh-huh.
I
saying
mean,
it's something, yeah.
that's a very common experience for me because like I don't usually like think in the a verbal sense. I can, but like it's not like my main mode, I suppose.
Right.
So,
But I guess the general definition of this is that it's beyond expression.
oh, so it fundamentally cannot be expressed in words. Is that what you're saying?
In words or language in general. So people will say this whether they know English or whatever. I mean, English, Chinese, Spanish, whatever. And I have to imagine this argument also holds up even if they know, like, Braille, or an olfactory language or whatever. I mean, it would be a thing, like, think about this. If all you knew was Braille, and you were normally deaf, and suddenly you were able to hear English for the first time, like, that would probably be beyond description.
Well, it is describable. You just don't know how to describe it in the languages you're used to.
So does that mean you now have to create a new language or a combination? You run into the same problem about, okay, that thing can't be expressed in that way, in that medium. Now you have to make another way of doing it, but you're still running into the origination problem.
I was just thinking about Helen Keller when she, one of the first words that she learned not as a baby, but like as an older child. Her teacher would like sign letters using some pattern into her palm. And so she would write out in water and then put her hand under the faucet and keep doing that and just repeatedly associate this pattern with this substance. And she learned that, okay, now I have like a word, I have like a pattern that I can map to a phenomenon, and then started learning language after that. And it was like
I
a
mean,
real big aha
yeah,
moment for her to finally have some traction in the space of thought and the space of communication. And I would imagine
yeah,
that, yeah,
yeah.
that
And
her
again, it's just,
cognition
it's,
is sort of in the space of concepts.
I guess another way to would be interesting to test this is like, let's think of, let's diversify our definition of languages. Like, I know people talk, I
Yeah.
think I know like Levin talks about like mind blindness and the ability for us to not recognize mind-like properties elsewhere, which is kind of interesting historically when you think about anthropomorphization. Like we actually do that, but I think we've, in a lot of ways, in sort of the modern world, we're sort of conditioned against it. But seeing everything as a mind and mind-like is definitely not new to human history. If anything, this is how we thought about things for a very, very long time. It would seem. But the other sort of example is think about language and communication and all that, right? Is like, what do you consider a language? Like, okay, we can say it goes past English and, verbal languages like that. It can go past things like Braille or sign language. It can go into the olfactory language category, whatever, right? I like to always,
Mhm.
include that example. But then what else? What else is the
Computer
language?
programs. You
Yeah,
can
but
make a
that's
language of
that's
programs.
Yeah.
that's still pretty close to the way we normally think and talk about things. I'm saying,
Yeah.
are there languages that are just so far off, from our current way of experiencing and understanding things, right? Because I think that would also sort of align up well with the idea of the experiences that you have no words or ways of expressing. I mean, sometimes even you can't even express it to yourself. Like, think about this also another thing that happens. You know what you were thinking of, but you don't remember the actual thing. Or if something is on the tip of your tongue. Like, isn't that interesting? Like, it's there. I wouldn't say
So
you've truly, forgotten it or whatever, but oh, what do you mean it's on the tip of your tongue? Like, you know what you want to say, but you can't say it.
yeah,
There's
so
like an
that's
I know
how I
what
there's
you.
said
like
to
the
word.
interface of the idea or the memory is sort of displaced, but the actual thing is still there.
Yeah, this happens a lot with
But I
focus
don't.
aphasia, that the speech center of the brain where you make words come out based on thoughts coming in gets broken. So like you think of the thought, you know what you're thinking about. You can't find the word to do it. It's just not there. Or that signal is deteriorated. So sometimes it's there, sometimes it's not. Reforming
So
those connections is pretty hard.
so I view consciousness in a purely computational way. Like I suspect it's a purely computational phenomenon, and as a result, I think that if you're there's like probably a way you can describe any like qualia in terms of like some like data, like a program, like what the color red looks like, that Olo thing, basically anything really. So, and that is always like expressible via a program. So I don't think there's anything outside of that range. I think that every conscious experience can be expressed as a program. I guess I'm saying.
Can it be expressed as something else that you wouldn't consider to be a program, even though you said that everything is sort of computational? Is there a way you can express it and say that you would say it's not a program?
Well, you can. Have you heard of conlangs? Yeah, you have actually.
Oh, of
Basically,
course,
you
yeah.
could, yeah, just make a bunch of like random data, and you can just create an arbitrary conlangs which interpret that arbitrary data in all sorts of ways, like such as a program which corresponds to some sort of qualia. Like I guess you need some agreed upon syntax in order to like do it properly.
Well, I guess on the topic of that also, since I'm driving right now, I could also sort of say, if you think about if you were to take cars on the road right now, whether I mean, I'd say especially in a city more than like a long, state road highway kind of thing. If you were to take a car that's in a busy city, we'll say Austin, Texas, maybe, right? If you were to just abstract away the fact that they're cars, and in fact, let's go a step further, remove the fact that they're cars and reimagine them as if they look like animals. Like the way
Yeah.
cars communicate and coordinate with each other on a busy road is in a lot of ways similar to what we think of that animals are doing in like a proto language. Like they're
Yeah, like a
giving these
herd,
pretty, yeah,
navigating a herd, moving across the plains or something, like buffalo, because they're about car length, and so they would come across some of the same patterns and merging issues, and it probably have like, I need to I either need to pass you or get or like merge or do something or maneuver in relation to you, or and we need to coordinate our movements. I'm sure that they would have some of the same words, that is body signaling or positional signaling, to
right,
tackle some of the same goals.
right. Yeah. And, like, I think people, you got to be really thankful for turn signals and brake lights. Like, those things are helpful, man. Like, those are
Signals.
really
Yeah.
helpful. Those are
Oh
really
yeah.
helpful, man. I mean, seriously.
Hmm.
It would not be a fun time if we didn't have those ways of doing it, right? I mean, I think there's other ways of doing it for sure. And
Right,
it would
right.
it
So
would be
like,
very interesting. Yeah.
if you
Go
wanted
ahead.
to signal your intentions to merge left, like you might like wiggle a little bit if you didn't have a signal, turn signal, right? You just kind of like wiggle and go back and say like, oh, I'm gonna go this way, and then someone might let you in. Just thinking outside the box there could be body signals
Yeah.
or positional signals,
I mean,
positional
again,
based
that's
signaling.
that's that's a means of coordination.
Yeah.
That's a kind of language. I'd say it's a more diverse form of language than the way our sort of standard definition of things like English or whatever. This also sort of goes back to the big idea of like what other languages could cars have when they're communicating with each other in this way? Because I think you do see a similar thing. You see it in trucks. You see it in and even people just bicycling.
Uh-huh.
Like you want to be seen, especially if it's at night. Like you have the reflectors, you have all those things. I mean, streets have reflectors for that reason, so that you know that it's there because if it's rainy, foggy, or really dark or whatever, like it's not immediately knowable to you that there is this boundary that's there, right? Like okay, you need to have some kind of indicator, some kind of constraint that's put there. And it's like, what would be the minimal model of having, a car or a city where they would naturally evolve these kinds of signals or language? Because this again goes back to the origination thing of, combining very different things or looking at a stone and being like, oh, it's obvious that this can create fire, right? Like if you
Hmm.
think about an IQ test, I say this is sort of the limits of intelligence or knowledge in a sense. If you don't have, if you're solving a number sequence, right? Like just a simple thing like a number sequence, if you don't have enough of a prior constraint, it could be literally anything. If I just tell you, x plus y, or sorry, 1 plus x equals y, that could be anything. 1 plus x equals y you could fill in anything for x and y.
Hmm.
It could be anything. It's an explosion
Well,
of possibility. And yeah,
confined to the numbers or things that are they can add together. Like mathematically, like saying plus one to x is assuming that x is something that you can add the number one to, which
that's
would
also true.
kind of suppose that x is a type of numerical quantity.
That's true. That is also true. I guess in the other example, I would say, let's say, and actually this has applications for very, very real world things, but let's just say abstractly, right? You have two roads, left and right. You can each direction is completely identical to you,
Hmm.
right? left and right, 50-50, they're identical. Where do you turn? Where do you go? Sure, it doesn't, I mean, it doesn't, if it's the same, you could go either or, but why would you go in either? Like, you're still going to make a decision about going left or right, but you have to be able to say, why did you go in this direction? And we, again, abstract past, oh, like I feel like this or do whatever. Like, let's think about it more abstractly, right? Like, if both options are completely identical and it's assumed that you have no kind of bias or things we think of as the bias.
Yeah. Identical options, no bias. How do you choose between multiple options? I mean,
Exactly.
you might try to come up with a random choice in your mind. You could outsource that to like flipping a coin, or you could do it yourself. Just say like pick one at random, kind of thing. That gets complicated because I don't know why it gets complicated. I mean, that's how do you like maybe it's pseudo random your choice, or it's bias based because you're right-handed and you go right because you just like
Right.
choose something.
But yeah, like, I mean, in a real world situation, a way to sort of look at this, right, is, you can have a lot of times if you find yourself in a situation that's more ambiguous like that, you'll notice yourself relying on your memories or, oh, is there something I didn't notice or forget or whatever? And yeah, in that situation, you could say, okay, sure, like maybe there's one little context clue of something you remember that tells you you should go left or right. But I mean, let's just say you have you don't have recollection, you're in a maze or something like that, all right? You have no recollection or knowledge of the actual structure of the maze, right?
Mhm.
And it's just pure darkness. You only have two roads, left or right, and they look exactly the same to you. Like, where are you gonna go? It's both exactly identical. Let's abstract away those details, right? There, I mean, you don't necessarily have a reason about where you're supposed to go. There's no. I think that's something where whatever we call intelligence or whatever sort of breaks down in that area. There's not necessarily a way to say without other forms of constraints that you're putting in, but should you go left or right? Now, on one end, you could say there's something which ties into that religion conversation we had after the salon at the dinner thing. But you could say that an aspect of intelligence is you're making that kind of blind choice. You're going right because you're going right. You're going left because you're going left. There's not necessarily a reason for it,
Yeah.
right? You're taking it's something sort of else, right? And the way you can think about this is like when you learn a skill for the first time, like you're gonna be wrong. Like when if you try to learn a language for the first time and not have somebody strictly teach it to you, like your associations are probably gonna be wrong when you're
Mhm.
associating different symbols or things together. I mean, we do this even in our normal life all the time. Maybe wrongly associate or correlate things or whatever. And yet somehow continuously doing that eventually trends you towards the thing that is correct. So in one way, you're saying you're making a wrong choice, which eventually leads you to
Well,
something
now you,
correct.
well, is that implying that the other choice was wrong?
Well, you may not know it's wrong until after the fact.
Okay, so I guess that's why you brought up a maze, because like at some point there's cheese
Right.
and otherwise there's nothing. So you
Yeah,
want to
that's
go to the
only
path where the
after.
prize is. Yeah.
But at first, you don't know. Like if you gave me, again, pretend I had no knowledge or basis to constrain the way I think about this, right? Just sort of clean slate. Like, I think a lot of these things you can learn by how we get to how we learn and we do things when we're very, very young before we really know much, right? If I were learning a language for the first time, I wouldn't necessarily know if this thing is the right association to make. Oh, this symbol goes with this meaning, or this symbol goes with this other thing, or whatever. You don't necessarily know that. That's only something you're drawing from very, very limited information in the given moment. And you're probably likely going to find out that, oh, that's wrong. I have to now update my belief, as they say. You're going to have to go
Mhm.
and correct that after the fact, right? But why is it that you can make an association that's wrong, and then if you keep doing that, eventually you can do it where you'll be able to update and change that. Because if I didn't know any better and I just said this, it's like you're saying you're doing something wrong that eventually leads you into something right.
I mean, this isn't. This is kind of like how AIs kind of learn in a sense, because
Right.
like they're able to use like their past, or no, that's not the right way to describe it. You guys know what I mean, though.
The,
Yeah, they
yeah,
get
I do know. I do know.
a negative hit on their function, right? Their fitness function, and they can back propagate that to like tweak the most appropriate neurons that are most responsible for that negative response, and tweak them in such a way as to get a higher value in the fitness function.
Yeah.
So
Yeah.
yeah, I
And
mean they
it
learn from
does
their
sort
mistakes
of
all the time.
remind me, like, when you're doing a number sequence or doing the, RPM matrices or whatever on a test, like your first assumption that leads you to the next number or symbol or whatever is not complete. It's not the full thing. It's in a sense it's not fully correct, but it's enough to get you to the next step, to get you to the next step. Until then you can say, oh, this is a full picture and I can change after that. Right. Right. It's like when we say, like, it's an interesting thing that you can update things. How is it that you can do something that's completely new to you? You can get it wrong, and then continuously doing that in each step eventually trends you towards something that's correct. And now, by the way,
Well, I can give a
I want to
simple
be careful with
example.
how I'm wording that, because there's something people will talk about where it's not practice makes perfect per se. It's perfect practice makes perfect. And it's that, there's plenty of times where you can train on the wrong thing and you'll stay on that. But what's the thing, again, abstractly, beyond just human minds, whatever, that lets you get to the next step, that lets you correct these things, and that that you should be correcting those things? Because sometimes if you put yourself in a very ambiguous, confusing situation, it's not entirely obvious that you should change this specific belief and not something else. Right. Like, I was talking with a friend recently about this. When you get something wrong, right? Whether it's a number sequence thing you're doing on a piece of paper, or just things you're doing in real life, you have to be able to know it's saying, don't do this. It's not telling you to stop entirely. It's telling you to not do a specific thing. And I think sometimes that happens with things like, people that sort of get very, unmotivated, or they lose their drive, or direction to things, is that they overgeneralize the failure, the negative feedback. Like, they sort of interpret it as, okay, it's all or nothing. Like, the whole thing is rubbish. When realistically, the productive way, you could say, is that you're saying that no, it's the feedback is saying no to this, not the whole thing. Right? Like, I mean, sometimes even just in my own life, when I look at things, it's like, is the feedback telling me to not do this, or is it saying maybe don't do all of this? And again, with very simple things, you could say, okay, it's obvious to us because we understand things kind of in the way that we've learned mathematics and logic or whatever. But is that necessarily obvious to a baby or someone that's drunk or high? And again, I say this on purpose because I think it's helpful to get a deeper understanding of these principles by looking at very diverse forms of mind and perception. Like, what kind of learning logic association system are people doing when they are, high or drunk or whatever? Like, I'm willing to bet you probably could learn things potentially even very well while you're high or drunk. Now, I mean, there's lots of musicians that say they learn better, or artists say that they learn better on these things, even though we typically associate them with sort of ripping apart your logic in a lot of ways. And the other is like, where does that internal logic system come from that you should associate things? Like, how does a baby know to associate these things? Okay, yeah, we can say, oh yeah, associate this face is visual information. This is my mother, or this is someone close to me, or whatever. Where does the act of associating and connecting things even come from if it's completely novel to them? So again, this is now getting very philosophical, but I think this is actually very important to building cognitive systems and modifying them. Where does this stuff actually come from?
I don't know how much this helps answer it, but I recently came across a YouTube video called Learning Algorithm of Biological Networks. And if I remember correctly, it suggests that like a realistic learning model for neurons uses like some sort of like prediction mechanisms where they can predict the effects that they're going to have like downstream, and that gets like fed back into them, and they like use that to see if that like if to see if their predictions match up with reality, and they refine their outputs based on that. There's probably something you could do there.
So that's cognition is prediction and back propagated by getting it wrong or adjusting things to get it right. Is that a good summary of what you said, Michael?
Yes.
Yeah, I mean that seems
Yeah.
quite reasonable.
I'm just thinking about like if you were gonna build a mind from scratch. I mean, this all ties back into the origination and novelty thing because it's like if you hold the assumption that life or mind came from something that wasn't life or mind, what is it about that that leads to that, right? And you don't even necessarily have to say life came from non-life or mind came from no mind. It could just come from something very far apart from it, right? How does that lead to that? I think all this is also very much tied into the origination of what we call life to begin with, or mind or consciousness or whatever it is. And I
Yeah.
think saying that it's, everything is life, everything has always been consciousness. Even if that's true, that doesn't necessarily get us closer to what we're trying to do and create new kinds of mind or new kinds of life or whatever, right?
Mhm.
Whether or not everything is a mind, everything is consciousness, everything is life, whatever. The rock has some kind of life or consciousness or cognition, and I wouldn't even mind agreeing with that and saying that, but that doesn't necessarily get me closer to okay, can you make a rock learn something? I guess a very interesting, trippy way of thinking about it is how do enact can is there some way, if you change your definitions of it, that you could say that things that we consider to be inanimate objects can learn, right? And chemically, a rock will have changes. If you condition a rock, you can change its different properties, and that becomes a part of the rock, right? Like it's
Mhm.
interesting. Like if you do that, and you just you have a time lapse of it, and you speed it up, it'll look like the learning process, right? Like I had this thing I did many years back as a kid where like if you speed up video of a bunch of like inanimate objects, it starts to look like it's alive.
Mhm.
Like random
Like those
rocks,
rocks.
pebbles, dirt moving, sand moving, clouds, the ocean, all these things. If you speed it up enough, it literally looks like a living organism.
The sailing rocks in the desert are a nice example. I mean, they kind of,
Yeah.
I mean, they started getting blown by the wind. I mean, but if you time lapse that, just watch these things kind of move across.
So I think, we have, if we talk about diverse forms of mind and language, that I think learning, the aspect of learning and adaptation, diverse forms of adaptation and learning are equally part of that kind of idea. And there's things like annealing for materials. That is in a sense you could say that's a kind of learning,
Right.
right? And the key is okay, cool. We're saying all these things that we're already doing could be thought of as learning. Okay, nice. Now can we make something more adaptable or have more learning ability? That's going to be the interesting thing is can you have you could say the metal has a certain learning property to it right now if you do, but can you get it to learn more? When we say we're trying to enhance intelligence in humans or AI, we're trying to change the way it sort of learns and does these things. What does that look like for other materials and objects, right? And then at that point, you're talking about do things like chemistry and physics have some kind of agency to them? Very, very minimal forms of agency to the reference point of a human, you could say. But are they also doing something that could be similar enough in a far-fetched way to saying that it's learning and adapting to things? Things
I
change.
mean,
I
everything
I
Yeah.
think changing
physics,
in
Yeah.
and of
Yeah. So I mean,
itself,
I
right?
would. It's alive or it learns if it can have like some sort of memory. Like Michael Levin would talk about gene regulatory networks
Right, right.
being just a combination of genes, and then they exchange like attributes between them a certain way. Sometimes you could stimulate them in a certain manner to have them and then have them remember that or store it in as type of memory and then respond to the same stimulus differently the second time.
Right. And something I've actually also spoken about this before, but I always bring up the idea, the sort of question about why is it everything that we say is sort of like a brain or a nervous system or life or whatever is sort of soft and squishy. They'll have something like a skeletal structure where it's the harder structural aspect. Why is it that you see those patterns in anything that we call life, even things down to bacteria? Yeah, it's not literally soft and squishy in the same way your brain is, but relative to each other, they're like that. There's a structure that's like the skeletal system that keeps the whole thing, stuck together. And then there's the things that are more flexible and they change. And, when I would think about this, I'm like, if I were to build learning machines, right? And I want to have a lot of variability and room for change. Like, let's say I start off building it with very hard materials. The last thing I was going to finish on that I would think about is like if I were to build, a system for extreme adaptation, right? Like something that's just really good at adapting to things on the fly, doing whatever. If I build it out of very hard materials, if I want it to change itself, it's going to be a lot harder. But if it's something that's sort of softer mixed with things that are a little harder, you have the thing that sort of keeps the skeleton in place. You need to keep some structure, and then everything else is more pliable and plastic and can be changed. Like if you have, if a robot wanted to modify its the properties of its shell, like it would be easier if it had a way to do that with vessel-like systems in its skin that it'll start to look like it's like a biological skin, whether it's a reptilian kind of surface or human skin or whatever. Is that if you're trying to go for extreme fast acting adaptation and you want to keep it to the organism and not having to rely on something outside of it like the human to say fix your robot, it's going to start to look like biology. I don't know, at least in my head. Anyway, go ahead.
Yeah, so you're right that a lot of smaller organisms can evolve faster, and they can reproduce faster.
Correct.
If you want something that's like most adaptable to new circumstances, I would think bacteria are the way to go about that. Fungus, which a fungus isn't really a plant or an animal; it's like just a eukaryote, a little bit different. There are some fungi that will have spores that like uproot and like march over.
Correct.
You
Correct.
know,
Correct.
you got to wonder what kind of communication are they telling to each other in order to coordinate that behavior.
And
Multiple
trees,
spores.
like I'm driving past a bunch of giant trees that are quite hard. I wouldn't recommend
Hmm.
punching those trees.
Right, right. But yeah, I mean, it's interesting that the biology of life on Earth is sort of predicated on the Lego blocks of amino acids
Right.
linking together to make protein, and then that's what we're all made out of. It'd be interesting to think about, well, what if there were like more mineral type of rocky bits in the microstructure that were incorporated? Like, how would that change the
I made a
uh
joke that like what would stone organisms or stone computers look like if they naturally evolved? Because if you look at certain minerals and crystals and all that, like they have that interesting kind of structure to them. Like if I think of things like bismuth, for instance,
mhm.
like would there be some initial conditions you could set where you could have these sort of, naturally evolved, cognitive or computational systems that are entirely like mineral based, right? At least
I
it
mean, I
could
don't
make
know
for a
that
good sci-fi story.
supposedly like silicon's like rather flexible like chemically
Correct.
in that regards possibly. I wonder if it'd have more ligand
I mean,
structure
how
than
would a
that.
computer and the way that we think of computers naturally evolve? Let's say it wasn't humans or whatever else. Is there some way you could run the ecosystem of nature and we could say, oh, it seems that sort of leads to biological life, but how would that originate a computer that didn't involve us making it? Like, how would nature naturally, quote unquote, naturally evolve something, like a computer in the way that we make them on chips and stuff like that?
I mean, our brains are computers.
No, but
Um,
I mean literally like a PCB, right? Because think of all the different places on the planet that you get all those materials from, and then you have to bring them together in a specific exact way to get this kind of thing. That's a large amount of distance you have to bridge. And
I mean,
even if you kept everything you needed together, that's not enough to say that it would just naturally form out. It's like that thought experiment about, like, if you had what was it, a monkey or whatever, go at a typewriter long enough for infinity, would it produce Shakespeare?
you could have a situation where you have an organism which is like no like fleshy like we would expect, but over time it like finds this like evolutionary pathway where parts of its like body is able to get like become like mineralized, and eventually more and more stuff gets like placed by it, and maybe it's able to function more in terms of like minerals in order to move into like a um niche in the environment where it's less, I guess, organic in terms of like carbony and more like silicates. I like it'd probably be very hard to do, but I mean maybe that's something which could just like at least like naturally occur somewhere.
I mean, you could make a good argument that, like, bones are, in a sense, mineral computers. And you could also make an argument that, like, certain harder plants, think, certain trees are, in a sense, they're not necessarily mineral computers, but they're like, naturally evolving computers of a harder material and substrate than a human or a jellyfish or whatever. I think you can learn a lot by how different crystals and things are, like, like, how the heck, like, isn't it crazy that diamonds can even be formed in the way that they are?
Oh, that's a really interesting idea that of like having bones like compute stuff. That definitely seems like
Yeah.
something which like should be doable.
Yeah, they're already doing it right now. That's why we're alive. And bone, how
Wait,
bones learn. Bones learn by literally by getting teeny tiny fractures. We call that, load bearing exercises with weights. We literally damage
what?
them slightly, and then they regrow a little bit stronger each time.
Well, I don't know if that's I would really consider that proper computation like you might be able to do with like a calculator or an
All
AI.
right.
Like you need something like different, but it should be doable still.
I see we've got Michael thinking about this now. Bone computing.
Yeah.
Yeah, we'll have to make that a whole topic for another salon where we just talk about that. But I think it's valid to say that it is a kind of computer, especially if you operate under the assumption that, these kinds of properties of computation are sort of an invariant to the way that we describe things. I mean, also, it's interesting if you look at, like, the different way different drugs or viruses or things change your bone, right? Things that you'd have genetically or whatever growing up, but then also just like certain things that are muscle wasting or bone wasting or whatever, like all those kinds of things, like the way that can completely change all the behaves and act these things. I mean, it's one of those, even though you could say the bone has mind-like properties or computational properties or whatever, like, we're not actually sitting and thinking about that, like, oh, do this thing, do X and Y, right? It's happening kind of below the surface for us, the surface
Hmm.
at which we're thinking and interacting and trying to control things. And it's like a car. Like, you're not actually sitting and individually going and moving each part of the engine or the transmission. You just put your foot on the pedal and
Yeah.
move the steering wheel. Or, if you're in a self-driving car, it's even less these days. All right, so there's a lot to this idea of your kind of the language of the interface is changing the way you're controlling all the other kinds of information and dynamics,
Yeah. The API
which
for our
also
body
goes
is
again,
just we just control the skeletal muscles. That's it. We don't do anything else.
yeah,
Yeah, we kind of get that for free in the same way all the and weird internal workings of an internal combustion engine are hidden from us. And we just have pedals
right.
that we press, steering wheel that we turn.
The thing that also tying into what you and I were saying just now about all this is that, like, it's like, again, it's the concept of fire. It's this thing that's hidden. It's not that there isn't something about the stones and the wood pieces that can't be used to create the fire. right? Like there has to be something that's creating the conditions, something cognitive, whatever it is that's creating the conditions, the initial conditions and minimal model to have the ability to conceive of a fire if you've never seen a fire before, right? Off of just looking at that. It's the same thing. If a kid is looking at a car for the first time, they're not going to know what's under the hood. They're literally not going to know what's happening under the hood, let alone what it looks like and exactly what it's doing. You would have to, even if you start, I'll put it to you this way, even if you start thinking, if you have such a good, simulation ability in your mind, working memory capacity, whatever it is, to picture every aspect of the car that you're seeing, I still don't know if that would be exactly enough to logic your way that there's something, there's this engine. Now, what you may be able to do is you may be able to say there's something like an engine inside, something like a transmission. You might be able to say there's something like it, it would be a different kind of thing, but it wouldn't be exactly that, right? And then you could then say about what are other things that are like fire that get you to the same endpoint of cooking your food or processing things or whatever, right?
Mhm.
At least in terms of destroying things, just hitting things enough with the right tool would pulverize things enough to maybe get it to the point where it could start to feel like tiny particles and dust. What about cooking, right? I would say, if the goal of fire was in a way to make the food better for you to eat, that's also what freezing, which is interesting because that's the exact opposite of fire,
Mhm.
right? You could freeze your food, you can salt it. Also, who the heck would have thought about putting salt, little tiny stones over your food? Who would have thought of that, right? And then also, like fermentation. Like, congratulations, you're literally getting a bunch of germs to reproduce over your food, and then you eat all of it.
Yeah, yeah. Cooking food is good. That discovery, I guess, is probably predicated on we have a fire going. It keeps us warm and the predators don't come, it keeps the wolves away. And just
I
human
mean, it probably
curiosity.
doesn't
Let's
keep.
stick stuff in the fire. Let's see what happens when you stick stuff in the fire. I mean, I bet some guy probably put his junk in the fire at some point. It's like, what happens if I do this? Oh, it burns. You would take objects, you put them in the fire just because you're bored, you're curious, and then same thing with food. That's got to be like one of the first things tried in the pursuit of novelty.
Right.
I mean, I don't really think that the fire kept wolves away because we have dogs.
Yeah. Any other lasting comments, ideas, or thoughts?
Just
Um,
want to emphasize the importance of language as as
Right.
as a means to construct complex notions.
Right. You could say language, in a sense, is in many ways that is the initial condition or model for these things. Like the language gives you a label to say what it is of all the different things that it could be what it is, or at least what you're trying to use it as, right? And actually, that opens up another branch about like, there's nothing about the letters of English that mean that in and of itself. It's only to the observer that's trained on that and created those associations, right? Like if somebody saw English for the first time and they came from another background, like what is there something about that would necessarily lead you into the way we pronounce words and talk about them in the way that we are? I think this actually is something mathematics is slightly unique on as well. There is something about the so-called unreasonable effectiveness of mathematics. I think there is something to that, at least right now, to my perception of things. Like there are a lot of ways you'd end up evolving mathematics on its own separately.
Yeah, yeah.
And again, you're not
Um,
using the same symbols. You're not using, but the inherent meaning is going to be the same.
yeah, so mathematics as a method for tracking patterns and predicting them. We investigated types of mathematics that are useful to describe phenomenon in the natural universe, in the natural world. And we should be so lucky that the natural world is the type of universe that has consistent patterns that it does these patterns, has
Right.
conservation of matter and energy, let's say. It's not a Adventure Time universe where random stuff happens out of nowhere for no reason.
Eh,
I like your Adventure Time example.
I mean,
Yeah.
matter
I
and
mean, if
energy
we
aren't
were living
really.
in a truly Adventure Time universe, like mathematics wouldn't be effective for describing what's happening there.
But
I mean,
let's say you're in the Adventure Time universe, like would the character just run with this for a second now, right? Like
Yeah.
would they evolve something that's like mathematics in order to make sense of it? Something that's a different logical structure. I don't know whatever word you'd use for it. But
Right, right.
I
So
don't
like
think it's
we
right
yeah.
to say, sorry, I don't think it's right to say that we're not in that kind of like Adventure Time like universe because in general relativity we technically don't have like energy conservation and we probably don't like have mass conservation either because in an expanding universe or actually a universe changing in size, particles which are like moving around like with like kinetic energy, translational kinetic energy, can either like gain or lose energy depending on the expansion or contraction, and light can have like it can increase or decrease in wavelengths, and therefore the amount of energy and momentum it has changes as a direct result. So like it's not really noticeable on like normal like day-to-day time scales, but like these aren't like hard rules of our universe.
Hmm, interesting. Um
Oh, Veritasium you just like made
yeah,
a
so I
video
mean
on
it's
that.
like a local rule. I mean basically like locally you have conservation of mass so that if you take like two apples and you have three apples over here, you put them in the same bag, you count how many apples are in that bag, you're gonna get five because dragons didn't pop out, right? It's still just
I think
apples.
that's
If every time you try to like add two quantities together in a bigger quantity and if you stack piles and you count them,
yeah,
and if every time it was random bullshit that happened that they started morphing into like this one went to like this stopped existing, this one turned into a newt, this one flew away because it's a bird now, you wouldn't try to do arithmetic. You wouldn't have that arithmetic pattern like being something that the universe does. um it might arithmetic might be a purely esoteric like fantasy that's carried out on paper, insofar as paper is something that doesn't like also mutate into like a dragon fly off.
you know what this reminds me of? If you were
Huh.
an observer who exists on like the scale of quantum physics, that's probably the kind of world you'd consider to be like an adventure timey thing. Uh,
Yeah, because it's you're in the midst of like fluctuations of energy that are basically random. At the same scale, it'd be like being in a very busy public pool, right? And everyone's like jumping around, and you're just like a little bug riding all these waves, and your world is pure chaos. You're not going to think about
yeah,
like, oh, here's a wave and here's a wave, and then like I'm going to think about adding them together because they're very ethereal. You're just going to be replaced by random fluctuations in the next time step anyway. So you're not going to do arithmetic.
and yet our world is built on that, and I'm pretty sure that's heavily relativistic too. So yeah,
yeah. It is interesting though about like Adventure Time is human made, and there's such a way where you can create a simulation of something that has, we'd say, different properties than the world you're living in, but yet it comes from the properties of the world that you're living in. Like even when we simulate things in our head, we don't we only incorporate the sort of logic and laws of physics if we've kind of learned about it and have tuned into it in a certain way, right? If again, a lot of this you can just learn by confusing yourself, getting disoriented, or even putting yourself back in the headspace of when you were first learning things as a very, very young child. Like things do seem random and unrelated to you. They will. To your perception, all these things, there's no relation there. What are you talking about? There is no relation there. It's all unrelated. It's all random, right? And when we learn, like when we learn something for the first time, when we learn something, we're assuming there's a pattern to it. Whether it's a pattern that we are specifically, describing or thinking about, we're automatically assuming there's a pattern to get out of that a pattern. Right? When we use a spoon, we're assuming it's a spoon, and so we use it as a spoon. Right? If I want to go from
Yeah.
point A to B in my car, it would be helpful to think of my car with the concept of a car, with the lens of a car, right? And so one thing I think about is that when you're learning something for the first time, and you can just do this with literally anything, like even if you've never learned, a skill before, whatever it is, like you're assuming there is something to be learned. You're assuming that there is a structure, there is a pattern, there's something that you can learn and adapt to. The moment you assume that there isn't and you act as if there isn't, you're not going to pick up on anything. So there's once again this thing that you're going back to about assuming there's this kind of structure in mind. If I want to model
Yeah.
something, computationally, like it's the bone, I'm acting under the impression that the bone is doing some kind of computation. And I'm talking about, I think we talked about this in another salon. I could talk about, the ocean or a waterfall or whatever as the kind of computer. I'm assuming and acting under the lens that this is, like a computer or like a mind. And so I'm going to try to describe it that way. Right. And this also now ties back to those experiences that you don't necessarily have a way of expressing, is that, well, it's interesting if you're assuming you're trying to describe it in terms of English, but you feel like you can't do that effectively. Right. I don't know. I just see I'm acting under the assumption and the view that these things are all kind of connected in various ways, right? Because I'll put it to you this way. If you're trying to learn something and you assume that you can't learn it and you're going to interact with it as if you can't learn it, you're probably not going to learn it.
Yeah.
So, I think that has much to say about a lot of the ways that we do things, right? I mean, it once again brings open the question about this idea of information and things being kind of dependent on the observer, the kind of mind, that you are. There's people that very greatly anthropomorphize their cars. Some people are said to have relationships with their cars. Now, I mean this in like a really, I think it was on TLC like 10 years ago. There was a meme video about a guy that was like in love with his car. But when we treat a car a certain way, like people that are car enthusiasts, like they treat their cars almost like, another person with the same respect. They're treating it like their child. How many times he will say, this car, this whatever is like my baby. Like they're looking after it. They're setting the right conditions for it to not get damaged or hurt. Like you're operating under the assumption that this has the value to you that, say, a child would or whatever. And so you're treating it like that. Now,
Yeah.
it also turns out that if you go into a social interaction and you assume the worst in people, and you assume that the interaction is going to go a certain way, it may end up actually going that way because you're going to act in accordance to that idea. But the stranger thing would be that, can you still act under the assumption of the opposite and then it trends towards a certain result? That would be something interesting to think about at another salon. Is something that trends completely differently from the direction that you started. So
Yep.
I don't know. We should probably wrap up for today. We've been going for a while.
Yeah.
Yeah.
Excellent discussion.
All right. Thank you, everyone, once again for joining this episode of Polymath Salon online. We're fresh off the big Ekkolapto Austin, Texas tour. We went to UT Austin. We went to University of Austin. That's UATX. Explored that quite a bit. We hosted our first ever UT Austin Salon, Polymath Salon. We had Scott Aronson and Dugan as the keynote speakers, talking about computational complexity and all sorts of cool things. Those videos are going to be up pretty soon. And we're definitely going to be back again in Austin, probably Houston, Texas as well, potentially at Rice University, doing more salons and stuff like that later this year. So definitely stay tuned for that. But yeah, we'll catch you all guys for the next one. Thank you.
Thank you.